This is part 4 of a review of polynomial functions. In this video, we will do some problems that you will find on the free response section of the AP exam, specifically FRQ 1B and FRQ 2B. This review covers AP Precalculus topics 1.1 through 1.6. If you appreciate this content, please give it a like. These problems are calculator active, so we will use our graphing calculator as needed. Number 1. The function g is given by g of x is equal to 0.35x to the third power minus 3.5x squared plus 11. Part 1. Find all values of x as decimal approximations for which g of x is equal to 5, or indicate that there are no such values. Let's enter g of x as y1 in the graphing calculator. Just hit the y equals button and type in the equation like this. Since we need to find where g of x is equal to 5, let's also enter 5 as y2. Hit zoom 6 to take a look at the graph. Okay, I would like to see the very top of the graph and the very bottom, so I'm going to adjust the window. Hit the window button. Let's increase the y max by a little bit so we can see the rest. And let's drop the y min by quite a bit. Let's let y min equal negative 50. We can adjust this later if we need to. And let's let y max equal 20. Hit graph again. Our goal right now is to find where g of x is equal to 5. So we need to find the x values of these three intersection points. So hit second trace and choose option 5 for intersect. Pro tip, right now the pointer is on the blue curve. The pointer will travel faster on the red curve. So I'm going to hit the down arrow, which takes me to the red. Now I can very quickly move over to the first intersection point, and I'm just going to hit enter 3 times. Enter, enter, enter. Negative 1.235. In AP Precalculus, your answers must be accurate to 3 decimal places. Let's find the next value where g of x is equal to 5. So hit second trace, intersect again, and I'm switching to red, and just move over to the second point of intersection and hit enter 3 times. Enter, enter, enter. 1.412 if you truncate, or 1.413 if you round. Now let's find that third intersection point. Second, trace, option 5, move to the red, and slide on over. Hit enter 3 times. Enter, enter, enter. 9.822. Part 2. Determine the end behavior of g as x increases without bound. Express your answer using the mathematical notation of a limit. The end behavior of g as x increases without bound means the limit as x approaches positive infinity of g of x. As x approaches infinity, in other words, as we go towards the right, g of x increases without bound. In other words, this limit is equal to positive infinity. That's it for part 2. Part 3. Determine the average rate of change of g of x on the interval from 1 to 10. Express your answer as a decimal approximation. Show computations that lead to your answer. On the interval from 1 to 10, the average rate of change of g will be given by g at 10 minus g at 1 divided by 10 minus 1. Let's use the graphing calculator to find the decimal approximation. Make sure you know how to make a vertical fraction on your calculator. You can either hit alpha y equals enter, or if you have updated software, try hitting alpha x and see if that makes a fraction right away. we need to do g at 10 minus g at 1 in the numerator. However, we entered g of x as y1 in the calculator. So we're going to type in y1 at 10 minus y1 at 1. We can make y1 show up by hitting alpha trace enter. So y1 at 10 is really g at 10, and then minus alpha trace enter, so y1 at 1 using parentheses, and then divided by 10 minus 1. So the average rate of change is 0.35. That's it for part 3. Part 4. Find the value of x where g of x changes from decreasing to increasing, or indicate that no such value exists. We need to find this x value where g of x changes from decreasing to increasing. This will be a local minimum. So let's hit second trace and choose option 3 for minimum. We need to move to the left of the minimum for left bound. So let's just hit this left arrow key until we get to the left of the minimum and hit enter. For right bound, we need to be to the right of the minimum. So here we are, hit enter. And then for the guess, get close to the minimum and hit enter. X equals 6.666 if you truncate, or 6.667 if you round. That's it for problem number 1. Number 2. Cars park in the parking lot of a local store. When the store opens at 8 a.m., t equals 0, there were 4 cars in the parking lot. 5 hours later, t equals 5, there were 21 cars in the parking lot. 3 hours after that, t equals 8, 14 cars remained in the parking lot. The number of cars in the parking lot can be modeled by the quadratic function L, given by L at t equals at squared plus bt plus c, where L of t is the number of cars in the parking lot t hours after the store opens. Part 1. Use the given data to find the average rate of change in the number of cars in the parking lot in cars per hour from t equals 5 to t equals 8 hours. Express your answer as a decimal approximation. Show the computations that lead to your answer. Let's define the letter A as being equal to the average rate of change we are about to calculate. That way, if it turns out to be a crazy decimal, we can use A instead of the decimal. On the interval from 5 to 8, the average rate of change in the number of cars will be given by L at 8 minus L at 5 divided by 8 minus 5. We were told in the setup that L at 8 is 14 and L at 5 is 21, so the average rate of change will be given by this expression. Let's type this in the calculator for the decimal approximation. The average rate of change is -7/3. We can write that down, but they also wanted a decimal approximation. So let's turn this into a decimal by hitting Math and choose option number 2 and enter. So -2.333. Let's also store this into a letter on the calculator in case we want to use the letter A. So let's hit store and then alpha A. So the letter A will now represent this entire decimal. That's it for part 1. Don't forget the units. Part 2. Interpret the meaning of the average rate of change found in part 1 in the context of the problem. I'm going to show you 2 different ways to interpret the meaning. The first way is to say the number of cars in the parking lot is decreasing by 2.333 cars per hour on average from t equals 5 to t equals 8 hours after the store opened. Notice that the negative sign is expressed by the word decreasing. If you say decreasing by -2.333, you will lose the point. Also, no part of this is optional. To earn the point, you must include the meaning, the units, and the time interval. Here's another interpretation that some students prefer. The average rate of change of the number of cars in the parking lot is negative 2.333 cars per hour from t equals 5 to t equals 8 hours after the store opens. Some students prefer this method because you don't have to talk about decreasing or increasing and worry about dropping the negative sign. You can just say the average rate of change is negative 2.333. Part 3. Use the average rate of change found in Part 1 to estimate the number of cars in the parking lot at time t equals 7 hours. Show the computations that lead to your answer. When they ask you to use the average rate of change to estimate a function value, they really want you to write the equation of a secant line and use that to estimate the function value. Whenever we write the equation of a line, we like to use point-slope form, which looks like this, because all we need is a point and the slope. For the point, we can use either of the input-output pairs used in the calculation of the average rate of change, because both of these points will be on the secant line from 5 to 8. We cannot use t equals 0 because that's not on the secant line. Let's use the point 5, 21. What about the slope? The slope of the secant line from 5 to 8 is the average rate of change from 5 to 8. We don't want to lose any accuracy, so let's not use negative 2.333. Instead, we can either use negative 7/3 or we can use the letter A where we stored all of the many decimals. Now we are ready to write the equation of the secant line from 5 to 8 in point-slope form. Y minus y1 is y minus 21, which is equal to the slope, which we are calling A. X minus x1 will be t minus 5. This is the equation of the secant line, but let's get y by itself by adding 21 to both sides. So we will have y equals a times t minus 5 plus 21. To estimate the number of cars at t equals 7 hours, we evaluate y at 7, which will equal a times 7 minus 5 plus 21. 7 minus 5 is 2, so y at 7 will equal 2a plus 21. Let's put this in the calculator. Since we did store the average rate of change into the letter A, we can just type in 2 and then alpha A plus 21. I'm going to write down 4 decimal places, even though the College Board will accept 3. Negative 7/3 is a pretty simple expression for the average rate of change. So if you prefer to use negative 7/3 instead of substituting the letter A, this is what your calculations would have looked like. Here's what that looks like when you type it into the calculator. Be careful. You're going to get a fraction here, but you're being asked for a decimal approximation. So if you put 49/3, you will lose a point. You have to hit Math and then choose option 2 for decimal and hit enter. And there's the 16.3333, just like we got before. That's the end of the problem, but before I end this video, I've been saying that we are using the equation of the secant line to estimate the number of cars at t equals 7 hours. But I want to show you graphically what I'm talking about. We can see that L of t is a quadratic equation, so it's some type of a parabola. But let's use the 3 input-output pairs that they gave us and a little quadratic regression to find an equation for this parabola. I'm going to hit Stat and Enter. And here I'm typing in the input-output pairs into L1 and L2. Now I'm going to hit Stat and switch to the Calculate menu, and I'm going to pick Quadratic Regression, so option number 5. Before I calculate the regression equation, I'm going to come down here and tell the calculator to store the equation as y1. So I'm going to hit alpha, trace, enter, and now the regression equation will be stored in y1. So just hit enter a couple of more times, and here's the value of a, b, and c for L of t. Here's the graph of L of t, and these are the 3 data points that we use to calculate the regression equation. In part 2, when we calculated the average rate of change on the interval from 5 to 8, we were calculating the slope of the segment from 5 to 8. A secant line is a line that passes through 2 points on a function. We used this point and this slope to write an equation for this secant line. This point is the value of L of t at t equals 7. In part 3, we were asked to estimate this value using the equation of the secant line. Our estimate was the value of the secant line at t equals 7, which turned out to be 16.333. Because of the concavity of L of t, we would expect the true value to be a little bit higher than our estimate. Hopefully now you have a better understanding of what we were really doing in part 3. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.